Radical expressions and functions in 6.1. We're going to find principal square roots and their opposites. We're going to approximate square roots, identify radicands, find outputs of square root functions, graph square root functions, and find domains of square root functions. We're going to simplify radical expressions with perfect square radicands, find cube roots, simplify certain expressions, and find outputs of cube root functions. We're also going to simplify expressions involving odd roots and even roots. So what does this 4 squared mean? 4 squared means that you're taking the number 4 and you're multiplying it by itself. Since this is a 2 as our exponent, we would do 4 times 4, and we would list 2 of those, which is going to be 16. When we have something in the parentheses, that means that we're also going to do that 2 is going to apply to both of the things inside the parentheses. So this would be 4 times 4 as well, which is 16. Now this 2 doesn't have a parenthesis. So this negative here really means -1. And then 4 squared is 4 times 4, which is going to give me -16. This one's different because this negative is also inside the parentheses. So this is saying to square this whole thing. So -4 times -4 is going to give me +16 because a negative times a negative is positive. Okay, 1 squared. Okay, I'm not going to write every single one of these out, but 1 squared is 1 times 1, which is 1. 2 squared is 2 times 2, 4. This is 3 times 3, which is 9. 4 times 4, which is 16. Okay, so we're basically multiplying these numbers by themselves. 7 times 7 is 49. 8 times 8 is 64. 12 times 12 is 144. 121. 10 times 10 is 100. 9 times 9 is 81. That's what happens when we square something. Now, this little symbol, the square root symbol, means that we're doing the opposite. So if we've got the square root of 1, we're looking up here and seeing what the answer is and saying, well, what number times itself is 1? Well, that's going to be 1. Okay. Now, the square root of 4 is 2 because we can rewrite that as 2 times 2, and we're looking for a pair of the same things that are going to equal that. Okay, the square root of 9 is 3 because 3 times 3 is 9. The square root of 16 is 4 because 4 times 4 is 16. These are the ones that you learned probably when you were in high school. So this doesn't come as a shock to you. So these are just our basic square roots. So 14 times 14 would be 196. Now, one thing I do want to point out to you, and we'll probably talk about this again, is the fact that if this has a positive answer, they also have negative answers. So here's what I'm trying to say to you. If I want to look at the square root of 4, okay, there's 2 ways I can think about that. One way is I know that 4 is 2 times 2, so the square root is 2. The square root of 4 is 2. But also you have to recognize that that -2 times -2, well, that's also 4 because a negative times a negative is positive. So this actually has 2 answers, 2 and -2. If we look at 9, okay, we know that the square root of 3 times 3, okay, 3 times 3 is 9, so that the answer would be 3. But what happens whenever we take the square root and it's -3 times -3? That's going to give me -3 as the answer, because a negative times a negative is also positive. So every one of these actually has, we could go and put, it could be a +1 or a -1. The answer to this could be a +2 or a -2, +3 or -3. You could go back and put plus or minus with every single one of these. Okay, and I don't know that I'm going to take time to do that, but it has the other half is also an answer. Plus or minus is also an answer. Okay, so when we raise a number to the second power, we say that we have squared the number. Sometimes we may find or need to find the number that was squared. We call this process finding a square root. Okay, 5 is a square root of 25 because 5 squared is 25. -5 is also a square root of 25 because -5 squared is -5 times -5, which is 25. So that is what I was just trying to tell you. So if you take the square root of 25, it's got two parts. Okay, we could say, well, that's 5 times 5, so the answer is 5. But it's also -5 times -5, so the answer is also -5. Both of these would be correct. It says find the two square roots of 49. Okay, so we know that 49 is 7 times 7, and we know that the square root 49 can also be -7 times -7. So we have one answer that's positive and one answer that's negative when we take the square root of 49. Okay, so when we find the square root of 121, we've got 11 times 11, so we know the answer is 11. But also -11 times -11 is also 121. So the answer is both of these. And then a lot of times the way people write that is plus or minus 11. That's indicating that it could be positive or negative, that value. Okay, every positive real number has two real number square roots. 16 has a -4 and a +4 as square roots because -4 squared is 16 and 4 squared is 16. The number 0 has just one square root, and that's 0. Negative numbers, this is important. Negative numbers do not have real number square roots. If you try to type the square root of a negative number in the calculator, if you type in the square root of -9, it's going to say something like non-real. It won't work. You cannot take the square root of a negative number, and there are actually imaginary numbers, as crazy as that sounds, that help us to solve this type of problem. We just don't have to do it right here in this class. So you can't take the square root of -9. So the principal square root of a non-negative number is a non-negative square root. The symbol, the square root of a, represents the principal square root of a. To name the negative square root of a, we can write negative square root of a. Okay, so they're wanting us to simplify this. So the square root of 16 is 4, and we know that because the square root of 16 is 4 times 4, but we also know that, so that would be the principal square root. That's what they're talking about up here, that you would just do the positive side of it. If you want to look at the negative square root, you're going to purposely stick that negative in the front of the A. So we're just talking about our principal square root. They're saying don't do the non-negative one. They're focusing on that. So simplify 9, the square root of 9, well, that's 3 times 3 is 9. So the answer would be 3. They want you to simplify the square root of 64 over 100. Well, the square root of 64 is 8 because 8 times 8 is 64. The square root of 100 gives you 10. And that fraction reduces to 4/5 because we could divide the top by 8. We could divide the top by 2 and the bottom by 2 to get our 4/5. When we do this, we're really taking the square root of 25 over the square root of 81. Where the square root of 25 is 5, the square root of 81 is 9. And we're not, on these, we are choosing to not look at the negative portion of this. We're just keeping these positive because that's what the direction said to do. Okay. Now they are putting a negative in front of this, and because they're pointing out, oh, we want it to be the negative one. So this answer needs to be negative 12 because 12 times 12 is 144, and they're saying make it be the negative answer. Same thing here. They're saying negative. Well, 11 times 11 is 121, so that's going to be negative 11. This one's going to be negative. Okay, you're going to take the square root of 16 over the square root of 81. So negative 4 ninths. Okay, this one, simplify 0.0081. Should be 0.009 because when we multiply 0.009 times 0.009, I might have one decimal off there. Let me check that real quick. Yeah, we don't need one of those. Because 0.09 times 0.09 is equal to 0.0081. And that's how I knew I was wrong, because this only has 2 zeros as decimals, so I had an extra 0. Okay, so on this one, remember, this is not possible. This is, actually, it is possible. Let's just put it is not real. So you cannot take the negatives on this one is underneath the square root, which makes it different than these others with the negative on the outside. This is not real. It's not something we're going to do right now on this class. Okay. So it says use the calculator to approximate the square root of 74 to 3 decimal places. So they've typed this in the calculator, and then it says that they're rounding it to 3 decimal places. So 1, 2, the 2 would be the 3rd decimal place. And since the 3 next door is 5 or less, I mean, it's below 5, then we would leave it alone and put 8.602. Okay. They want us to use the calculator to approximate the square root of 83 to 3 decimal places. So let's go to the calculator and make sure that you're able to type this stuff in the calculator. So if I want to type in the square root of 83, okay, there right above this, if you go straight down this first row, we run into x squared. And right above that, there's a blue square root key. Yours might be a different color, but to get the blue to come up, we want to hit second x squared. Then it gives me a box, okay? And then it says we want to find the square root of 83. Okay, so we're going to hit enter. And it says it wants us to round that to 3 decimal places. So that would be 9.110, because the 4 right here is not going to force us to round up. This 4 would have to be a 5 or bigger. So 9.110. Okay. Square root of 129 over 49. They want us to do that one and round to 3 decimal places. So let's go back. Now this, it is possible to type it in just like it's written there. So I do want to take, I'm going to do second x squared to get my square root, but I want to take the square root of a fraction this time. And so I'm going to do alpha y equals to get my fraction key to come up, and I'm going to hit enter. And now it's letting me type in exactly, we can type in 129 and then arrow down and type our 49 and then hit enter. Okay, and it says it wants us to round it to 3 decimal places, so we would stop at the 2. But look next door to the 2, there's a 5. That's going to make that 2 round up to a 3, so it's going to be 1.623. So this one is 1.623. Okay, they want us to use the calculator to approximate this one. We've got a negative on the outside. That's important. Okay, if the negative had been on the inside, we would not be, it would be non-real, but it's on the outside of the square root sign. So I'm going to go and we're going to do second. Actually, we need to type in, let me undo that, because we want to type in our negative first, and then we want to type in square root. 8423.5, enter. Okay, and then they do want us to round to 3 decimal places, so negative 91.779. This 6 is going to make that 9 round up, and the only place it can go is to a 0, so that's going to make that 7 round up to an 8. So negative 91.780. Negative 91.780. That's how you kind of type those in the calculator. Now they don't always come out of decimals. If we had have gone up here in our beginning and typed the square root of 36, it would have given us the 6. The square root of 121 would have given us 11. So you can use the calculator to find the square roots too. Okay, I have been calling this, just because I feel like that's what you probably are used to, I've been calling this the square root symbol. But really in math, we want to call it, most people would recognize that it's a radical sign. This little house rooftop thing is a radical sign. We call it square root. An expression written with a radical is called a radical expression. So if you see a square root problem, it's called a radical expression. The expression written underneath the radical is the radicand. So it's got the square root of 5. Well, the radicand is the part that's written underneath the square root, which is 5. The radical of a, the part underneath, is the radicand, which is a. The negative has nothing to do with the radicand's outside the square root. So the radicand is what's underneath, is 5x. And this one is y squared plus 7. So the radicand is the expression under the radical. In this problem, it would just be 2x squared minus 7. Okay, the radicand in this one is what's underneath the square root, so it's just y plus 8. Okay. Suppose, so it is tempting to write the square root of a squared is equal to a, but the next example show that as a rule, this is just not true. Okay, suppose a is equal to 5, then we have the square root of 5 squared, which is 25 or 5. But if we have a is equal to negative 5, then negative 5 squared, which is 25, is also 5, and 5 is not equal to 5. We already talked about the fact that it had a positive answer and a negative answer. If a is greater than 0, the square root of a squared is going to be a. If a is less than 0, the square root of a squared is going to be negative a. If a is negative, the principal square root of a squared is the opposite of a. Okay, so we're taking the absolute value of that. So let's look at cube roots. So a cube root is very similar to a square root. Instead of doing this 2 times, though, if it's 4 to the third, we're going to do 4 times 4 times 4 to get our answer. Okay, and so 4 to the third power is 64. Again, you're going to apply that 3 to the parentheses, which is going to be 4 times 4 times 4, which is also 64. And this one's different. This negative doesn't go with the 3, right? It's not in parentheses. So this means negative 1 times 4 times 4 times 4, because the 4 is the only thing that's getting cubed. This answer actually turns out to be a negative 64. And this means -4 times -4 times -4, because you're cubing everything in the parentheses. That negative has to go with it because it's included in those parentheses. And a negative times a negative is positive, but then we're multiplying it by another negative, so it's going to turn back into a negative number. Okay, so 1 times 1 times 1, 2 times 2 times 2 would be 8. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. Now, we don't want to have to write this out every time, but if so, how do you type this on the calculator? 5 cubed. If I go to my calculator and I want to type in 5 cubed, you're going to type in 5, and then you're going to type in this rooftop button, which is underneath the clear, and then 3, and that's going to give you your answer of 125. So if I want to do 6 rooftop 3, that's going to tell me 216. Okay, so you can go to your calculator and you can type those in and get the answers. Okay, so 125. We said this was 216. 7 times 7 times 7 is 343. 8 times 8 times 8 is 512. This is 729. This is 1,000. And 12 to the third power ends up being 1,728. Okay, so the cube root of A is written with this little 3 up here. Now, when we have square roots, there was no number up here, but we know it's a 2. So if there's nothing written there, because you're looking for 2 things that are the same number that multiply to give you 4. When it's a cube root, they replace that with a 3, and you're looking for 3 things that are the same that multiply to give you that number. So down here is saying, what's the cube root of 64? Well, we're looking for, and that 3 is important. We're looking for 3 numbers that are exactly the same, that when we multiply them together, they give us 64. So 4 is the answer, because 4 to the third, or 4 times 4 times 4, is 64. So what 3 numbers that we can multiply together that are going to be exactly the same are going to give us -8? And right here, you might be going, whoa, you said you couldn't do that if you have a negative underneath the square root. Well, that's correct, but this is not a square root. This is a cube root, okay? So we can do this, because -2 times -2 times -2 would give me -8. So the answer is -2. This one, our answer is -3x. And the reason that that's our answer is because -3 times -3 times -3 gets me -27. And x times x times x gets me x to the third. So -3x cubed is -27x to the third. Okay, 8x to the third, and they want me to cube that, take the cube root of it. So I'm looking for 3 numbers that are exactly the same that are going to give me 8x to the third. Well, I know that 2 times 2 times 2 gives me 8. X times x times x would give me x to the third, which means my answer has to be 2x. Okay, in the expression, the k root of a to the k, we sometimes call the k index. The number k is called the index, plural are the indices, for any real number a. If we've got even roots, if k is an even natural number, then when you take this Okay, if this number, these match, then the answer is going to be the positive of whatever A is. Okay, so if it's an even root. For odd roots, if K is an odd natural number greater than 1, it's going to be the same thing. Okay, we're going to get back A. If A is negative, though, it's still going to stay negative. So right here, we've got 4, the fourth root of 81. Okay, and I'm going to show you how to do some of this on the calculator, and I'm also going to show you how to do it, I guess, by reasoning and thinking this out. But if this is a 4 right here, I'm looking for 4 numbers that are the same that are going to give me 81. Okay, so I know that 3 times 3 times 3 times 3 is 81. So the answer would be 3 because 3 to the 4th is 81. And we're looking for 4 of those numbers. Now, how do we do these problems on the calculator? So I want to type the 4th root of 10,000 in my calculator. Let's go there real quick. How do we type the 4th root of 10,000? Well, there's not a 4th root button out here, but if you hit math, this right here will let you change what this X is to the 4th root. So that's the one that we want to pick. You can either hit 5 or just arrow down to it. Then you can put in, oh, I want the 4th root, use your arrow to go underneath the radical. We want it of 10,000, and it tells us the answer is 10. Okay. So what that means is that 10 times 10 times 10 times 10 is 10,000. And there's 4 of those, so the answer is 10. Now they're saying, oh, negative, and then we want something that has 7 of the same thing that's going to multiply to give me together to get me negative 128. So let's see if we can. I'm not going to worry about this negative on the outside right now. I'm just going to type in the 7th root of negative 128. So we're going to hit the math button, and you're going to go down to number 5. We want the 7th root of negative 128. Okay, and that is negative 2. Okay, so come back here. So what we found is that we did this part right here. We typed this part in our calculator and we got negative 2. And the reason that we got that is because negative 2 times negative 2, if we do that 7 times, that's 5, 6, 7, we would get negative 128, okay? Now we've got a negative on the outside already, and a negative 2 is going to end up being 2. Okay, we want the 5th root of 32. So and I happen to know that that is going to be, so we don't have to go back and forth. If you do 2 5 times, that's going to give you 32. So the answer to this would be negative 2. The negative part's coming from the minus that's already in the front. Okay. This one is different because the negative is underneath. So negative 2 times negative 2 times negative, all these need to be negative. Okay, so the answer is going to be negative 2. So negative numbers do not have real kth roots when k is negative. Thus, the 4th root of negative 16 does not exist as a real number. Okay, so this is one of those examples that if this is even, then this should not be negative underneath here. It's not going to work out. Now, here's one of those where we've got both of them raised to the 11th power. And what that means is, and that was in that definition, that if these two things are exactly the same, then the answer is just whatever is underneath. So here we've got a 7 and a 7. So the answer is 2x plus 1. Okay. This one's close, but I need to know what, it's not the whole thing raised to the 4th. Okay, it's only the x raised to the 4th. So could I write it with the whole thing raised to the 4th? I do know that 16 is 2 times 2 times 2 times 2. And so I could rewrite this as the 4th root of 2x to the 4th power, which is what this is, which would tell me that my answer is 2x. Okay. You could also take just in your calculator, take the 4th root of 16 and get 2. And then you know it's x to the 4th. So that's x times x times x times x. So that would be enough to make that 4th root. Okay. Negative 4th root of 81, x to the 4th. Well, we're saying what number times itself is going to give us 81 if we multiply it 4 times. So still got this negative out here. And we know that it's 3 times 3 times 3 times 3 is 81. And we've also got 4 x's. So our answer is going to be negative 3x. Because, right, this is equal to, because I've got 4 pairs of those. Here's some example work problems that you could, extra problems that you could work if you want to. But let's go ahead and cover 6.2. Okay, 6.2 really talks about some laws of exponents. Basically, if you've got two things that are exactly the same, the bases are the same, and you multiply them, what the rule is that you add the exponents. And we've already done some of this when we've been working through some of our problems. But an example of this would be if you had a squared times a to the 3rd, those bases are both a's. So you would add the exponents and get a to the 5th. Okay, if you're dividing them and the bases are the same, you subtract the exponents. So an example of this would be if you have a to the 3rd over a squared. To get the answer, you're going to go a to the 3 minus 2, which is going to be a to the 1st. These are how you this is how you simplify these. Okay, if you're raising it to a power, a to the nth power, then you just take the exponents and you multiply them. So if we had that, we would have a to the 3rd squared, then that really means a to the 3 times 2, which is a to the 6th power. If you have a negative exponent, that means it's on the bottom of a fraction. So an example would be if you had a to the negative 2, that's the same thing as a squared. You can get rid of the negative if you move the exponent to the bottom. The whole term to the bottom, it'll take away the negative part of the exponent. Anything to the 0 power is 1. Okay. If the exponent is on the outside of the parentheses, it needs to be distributed to both of the things on the inside of the parentheses. So if we have a, b, and we're raising things to the 3rd power, that would need to be a to the 3rd times b to the 3rd. Okay, and then the last one says if you've got a fraction, well, and it's raised to an exponent, it needs to go with both of the parts of the fraction. So if we've got a over b raised to the 3rd power, then that's going to be a to the 3rd over b to the 3rd. Okay, so it says consider a to the 1/2 times a to the 1/2. If we still want to add exponents when multiplying, it must follow that a to the 1/2 times a to the 1/2 is a to the 1/2 plus 1/2, or a to the 1st. This suggests that a to the 1/2 is the square root of a. So for any non-negative real number a and any natural number index n when n is not 1, a to the 1 over n means the non-negative nth root of a. Okay, so let me give you an example of this. If I wrote a to the 1/5, then this is another way to write that. That 5 would come up here and it would be a to underneath the root. Okay, if I say a to the 1/4, then this is going to be the 4th root of a. Okay. So rewrite without rational exponents and simplify if possible. And we've got negative 32 to the 1/5 power. Okay, so what they're asking you to do is to, first off, you need to know that these two things mean the same thing from that rule that we just talked about. Okay, so we're still looking for 5 numbers that are exactly the same that multiply together to get us negative 32. So that's going to be negative 2 because negative 2 times negative 2 times negative 2 times negative 2 times negative 2 is going to be negative 32. So that's why that's the answer. Now I'm going to show you on your calculator that both of these things mean the same thing. So we can type this, we can use our calculator and type this in. So if I want to take the 5th root of 32, that was one of them. So if we hit math and we go down to 5 and hit enter, and we want to take, sorry, should not have hit enter. I need to type the problem in first. Sorry about that. Do it again. Okay, so I want that to be the 5th root of negative 32. Well, that's equal to negative 2. Right. Another way to write that is what they're trying to say is if you do negative 32 and then rooftop, if you want to write the 5th root, you can type that in as a fraction and it would be 1 over 5. And you would get the same answer. Okay, they're both negative 2. These two things mean the exact same thing. Okay. Rewrite without rational exponents and simplify, if possible, 49 to the 1/2. Well, that means that we would put 49 under the radical, and then there's a 2 on the bottom here. So we would put the 2 up here. Now, most of the time, if it's a 2, remember, we wouldn't write it because it's just understood that it's the square root. So that's going to be 7 because 7 times 7 is 49. Okay. So if there's a 7 right here, then the power that we would raise that to would be the 1/7 power. Okay, negative 3x squared y. If this is to the 5th, or the 5th root, then it's going to be raised to the 1/5 power. For any natural numbers m and n that's not equal to 1 and any non-negative real number a to the m over n means this. Okay, so let's talk about that. So they've written 64 to the 5/6. Okay, look, the 5, the numerator goes on the outside and the denominator becomes how many of them you're trying to find, I guess. So we can write this as, so we can, when we figure this out, it's 2 to the 5th, which is 32. Okay, so 64 to the 2/3. Remember that the denominator part goes in the front, the numerator part goes in the back. So that means the cube root of 64 squared. So we'll use the form the cube root of 64 squared. And the answer is 4 squared, which is 16. So if we've got 81 to the 3/2 power, the 2, the numerator goes in the front, the 81 goes in the back underneath the radical, and we are cubing that, okay? So when we're finding the answer, we can also just type in 81 raised to the 3/2 power. Let's go look at that real quick. Okay, sorry about that. And that's 729. So we can use our calculator to come up with the answer here. Okay, this is going to be 15x, and then it would be 5/3, going backwards. So 15x to the 5/3 x. This one would be 9xy to the 5/4. Okay. Now, we have a negative exponent. We talked about this before. If you have a negative exponent, it's kind of like they're not reduced, so not really allowed. So you want to put them on the bottom of the fraction. So they've got an example that says 49 to the -1/2. And if you'll notice what they did is they moved it to the bottom. When they moved it to the bottom, the exponent's not negative anymore. And we know something raised to the 1/2 is just the square root of that. And then they took the square root. So 81 to the -1/2, they moved the 81 to the bottom and take the square root of that, which is going to give us 1/9. So rewrite with positive exponents and simplify if possible. So we have 1/25 to the 1/2, which we know that means 1 over the square root of 25, which is going to give us 1/5. Okay, 27 to the -2/3 would be 1/27 to the 2/3. So this is 27. Okay, and when you take the cube root of 27, that's 3, and 3 squared is 9. Okay, so this one, 32 to the -3/5 is going to be 1/32 to the 3/5, and then we're going to do 32. And then we could write, we know that we're taking the 5th root and we are cubing this. Okay, and I know that the 5th root of 32, 2 times 2 times 2, 5 times gets you 32. So this would be 2 cubed, and that's going to be 1/8. So convert radical expressions to exponents, use arithmetic and laws of exponents to simplify, and convert back to radical notation when necessary. Okay, so we're starting chapter 6. We finished 6.1 and 6.2 today. So if you're not finished with chapter 5, you need to try to get that wrapped up so that you can start on chapter 6.